Today we're going to look at the insertion sort algorithm. Insertion sort is one of the more basic algorithms which are available for sorting. We have other complicated, relatively more complicated algorithms like merge sort, heap sort, quick sort, but insertion sort and bubble sort qualify as the more basic ones in this list. We're going to take a look at the other sorting algorithms as well. Today we are going to focus on the insertion sort. This is a relatively simple algorithm. We'll just quickly run through the concept and the C program as well. So why is insertion sort called insertion sort? So insertion sort is called insertion sort because it runs a loop over each element in the array and it tries to find for each element which is its rightful place in the array to sort it according to ascending or descending order, so that it considers each element and it inserts it in its rightful place. So insertion sort is one of the more logical sorting algorithms you could come up with today if you didn't know what insertion sort was or what any other sorting algorithms are. You could come up with an insertion sort. That is how practical it is. So for example, most people give example of the deck of cards. If you have some different number of cards, like if you have 6, 7, 8, 9, 10, and it is shuffled like 7, 8, 10, 6, and 9. So how would you go about sorting it in a logical way? So what you would do is, if you want to sort it in an ascending order, you see that 7 is fine, it's the first element, and 8 is the second card. So 7 and 8 is also in ascending order, and you want to sort in ascending order, so it's fine. And the third element comes 10, so 7, 8, 10 is again in ascending order, which is fine. Now you come to the fourth card, which is 6. So what you want to do is you want to place this here, because then it would be 6, 7, 8, and 10. And then you would consider this last element and you would place it before 10, so that all the cards would be sorted in the rightful place. Now insertion sort has an added complexity because of the restrictions. We cannot just pick any element and place it wherever we want. So what insertion sort does is, when it wants to place 6 in its rightful position, it will consider all elements to its left and it will find out the correct position so that the array would be in ascending order. So how it would go about doing that is, in the first step it would swap with 10. In the next step, obviously 9 is always there because we haven't reached till 9. So in the next step it would again compare with 8, and we see that 8 is greater than 6, so it would again do a swap. And finally 7 is remaining, so it would again do a swap. So now we see that we have considered 4 elements and these are all in order. When the loop runs again, the only remaining element is 9, and similar activity will be done for placing 9 in its correct position. So this is the basic concept of insertion sort. Let's take a look at the C program, which is more or less on the similar lines. It's easy to understand. So suppose you have an array 4, 2, 3, 5, 1. This is where the algorithm starts. We are going to loop over each of these elements so that we can find out where to place each element. Obviously we don't need to loop over 4 because it is the first element, so we don't have any elements to its left side to place it in its correct position. So we would be starting with 2. That is why I have started I with 0 and not with I with 1 and not with 0. So this loop runs for the first time and I is 1, so that means ARR of I is 2, we are keeping this variable j to keep track of the left side of the current element so that we can loop over that as well for each outer loop. So currently I is 1 and j becomes 0. So when I is 1, ARR of 1 is 2 and j is 0. So ARR of 0 is 4. And now we are going to loop, this is the inner loop, and we are going to loop over the left side of whatever is there in the array to 2. So we compare and we are going to swap how many ever times we can. So ARR of 1 is 2 and it is less than ARR of 0. And we need this j greater than equal to 0 so that the loop doesn't run out of bounds, so that we don't compare like ARR of -1. So we want to keep this bound in place. And this part is the basic swapping which is being done. So we will swap 2 with 4. And we are going to reduce j as well to the left side, so that if there are any other further elements to the left side of 4, we can consider that as well. And we can place 2 in its right position. So after the first loop is run, we are going to get this array 2, 4, 3, 5, 1. So this is partially sorted till this place. Notice that we haven't considered 3 yet. 3 would be coming in the next outer loop. So when in the next loop I becomes 2, then j becomes 1 because we want to consider elements to the left of 2. So current element in consideration for I is 3 and we want to consider 2 and 4 now, which is basically now 2, 4, 3, 5 and 1. So current element is 3 and the just previous element is 4. So again we are going to do this. We will compare first 4 and 3. So this will swap this, and after this what we'll get is 2, 3, 4, 5 and 1. So j will then be decreased by 1 further so that we can compare with 3 with 2 as well. But then we see that this condition is not satisfied. So this inner loop runs till here only. So similarly for the next one as well, for 5 also this is run. So let's just consider the last step for this. So for first 4 elements we have run the algorithm and now we have 2, 3, 4, 5, 1. So this much is partially sorted for the array. So now I is 4. That means the current element is 1. We want to put 1 in its rightful place. And j would be just the previous element to that. So j would be 3. And we don't need this. The current element would be 1 and the previous element would be 5. So what happens in this inner loop is 1 will be compared to 5, and obviously this condition is satisfied. So when 1 is compared to 5, we see that 1 is less than 5, so a swapping needs to be done. So now what happens is 2, 3, 4, 1 and 5. Now we have till here. J is reduced, so again we will consider 1 and 4 now. So again a swapping would be done, so we would have 1 and 4. Now again j would be reduced. Now we would again end up with this, and finally we would end up with 1, 2, 3, 4 and 5, which is the final sorted array. And finally we will print the array. So let me just run this. Notice that I'm using this online IDE from CodeChef. So there are multiple IDEs available which you can use to run your program in any language. As you can see, all these languages are supported on CodeChef. So these are the steps, partial steps involved according to this, and the final result is printed here.